Hey, welcome. If you're a new operator, you're about to get to know one of the most important, if not the most important pieces of equipment in the whole plant. So in this explainer, we're going to break down everything you need to know about pumps, giving you that practical, real-world knowledge you need to walk onto the job with confidence.
So let me just start with a question for you. What machine is the absolute heart of every single industrial plant? Now, it's not always the biggest or the flashiest, but I guarantee you, without it, everything would grind to a dead stop.
You got it. It's the pump. And trust me, they are everywhere. I mean, from moving crude oil around in a massive refinery, to circulating critical chemicals, to providing cooling water for steel mills, and even just making sure our cities have clean water to drink. Pumps are really the unsung heroes of our world. They're the prime movers that make everything happen. So for an operator, understanding them isn't just a good idea, it's non-negotiable. So here's how we're going to tackle this. First, we'll look at the main families of pumps. Then, we'll basically take one apart to see what's inside. After that, we'll get into how they actually perform. And finally, the big one, what you need to do to get a pump started safely and correctly.
All right, let's dive right into the fundamentals. To really get a handle on any pump, you first got to know which of the two main families it belongs to. And they're really just categorized by the basic way they move liquid from point A to point B.
So, on one side, you have what are called positive displacement pumps. The easiest way to think about these is like a syringe. They trap a very specific, fixed amount of fluid and then just force it out. But on the other side, you've got rotodynamic pumps, which we almost always just call centrifugal pumps. Now, these work completely differently. They don't trap the fluid. Instead, they use a spinning part to fling the liquid outwards really fast, adding a ton of velocity, which then gets turned into pressure. So why is that distinction so important? Well, because in a typical plant, especially something like a petroleum plant, centrifugal pumps are the absolute kings. They're the workhorses, making up a whopping 85%, sometimes even more, of all the pumps out there. And because of that, for the rest of this guide, we're going to focus squarely on them. Okay, so now that we know we're zeroing in on centrifugal pumps, let's pop the hood and take a look inside. We're going to follow the path the liquid takes as it travels through all the key components. Here are the main players on the team. You've got the impeller. That's the part that does all the work. The casing, which is what directs the flow. Wearing rings, which are really smart little sacrificial parts designed to wear out so the expensive parts don't. And then you have the shaft, the seals, the bearings, and the coupling that connects the whole shebang to the motor. Every single one has a critical job to do. Right at the very heart of the whole operation is the impeller. This is the spinning wheel with these curved vanes on it. It takes all that rotational energy from the motor and transfers it straight to the liquid, basically slinging it outwards at incredibly high speed. This is where all the magic happens. But here's what's really cool. Not all impellers are created equal. The design changes completely based on what kind of fluid you're pumping. A closed impeller, for example, is super efficient, but only for clean liquids. A semi-open one can handle liquids that have some gunk or particles in them, and for the really tough jobs, like wastewater with big solids, you use an open impeller so it doesn't clog. It's always about the right tool for the job. Okay, so the impeller creates all this high velocity, but what we usually need is pressure. That's the job of the casing, which is often called a volute. It's shaped like a spiral, kind of like a snail shell. As that high-speed liquid flies off the impeller, it enters this expanding chamber, which forces it to slow down. And as it slows, all that velocity energy gets converted directly into pressure energy. It's simple, but totally brilliant. Now think about this. You have a spinning shaft coming out of a casing full of pressurized liquid. How in the world do you stop it from leaking everywhere? Well, that is the absolutely critical job of the seal. For you, as an operator, a leaking seal is going to be one of the most common signs you see that a pump needs attention. It is your first line of defense. Generally speaking, you're going to run into two main types. There's the old school method, called gland packing, which, funnily enough, is actually designed to have a small, controlled leak to keep it cool. But most modern pumps, especially the really important ones, use a mechanical seal. This is a high-precision device that's designed for pretty much zero leakage, which makes it way more reliable. Okay, so we know the parts, but how do they all work together? Let's talk about how a pump actually performs when it's up and running. This is where you, as an operator, can really start to understand the machine's behavior and what it's telling you. So to talk about performance, we need to get two key terms straight: head and flow. Flow, or capacity, is the easy one. It's just how much liquid is moving, measured in gallons per minute or cubic meters per hour. Head is just a fancy way of talking about pressure. It's the height that the pump can lift a column of that liquid. So higher head just means higher pressure. Simple as that.
And this right here shows the fundamental trade-off in every single centrifugal pump. It's an inverse relationship. The more pressure, or head, the pump has to push against, the less flow it can actually deliver. You simply cannot have maximum pressure and maximum flow at the same time. It's always a trade-off between one or the other.
Now, this whole relationship is captured perfectly in the pump's performance curve, often just called the HQ curve for head and quantity. You can think of it as the pump's unique fingerprint. And on that curve, there's a sweet spot called the best efficiency point, or BEP. That's where the pump is happiest, most efficient, and runs the most reliably. See, when you throttle a discharge valve, you are forcing the pump to operate at a different point on its curve. And if you run it too far away from that BEP, you're just introducing stress, vibration, and heat, all things that will definitely shorten the pump's life.
And now we've arrived at what might be the single most important section for you as a new operator, your role in a safe startup. This is where all the theory we've just talked about hits the real world.
Before you even think about hitting that start button, you have to do your pre-flight checks. Do a walk-around. Look for any obvious leaks or loose bolts. Make sure the piping isn't putting any strain on the pump nozzles. And this one's critical. Have you checked the oil level in the bearing housing? These super simple checks can be the difference between a smooth startup and a catastrophic failure. Okay, you're ready to prep for startup. First, and I cannot say this enough, line it up. Open that suction valve all the way. The cardinal rule of pumps is you never, ever run a centrifugal pump dry. It will destroy itself in seconds. Next, you gotta prime it by venting any trapped air out of the casing. Then, a quick bump of the motor just to make sure it's spinning the right way. And finally, for most centrifugal pumps, you're gonna start it up with the discharge valve closed. This just minimizes the load on the motor as it gets going. But your job is not over when you push the start button. Nope. Now you become an observer. Is the pump running smoothly? You need to be listening for any strange noises, feeling for excessive vibration. Check those seals again for leaks. Is the discharge pressure where you expect it to be? A great operator is constantly watching and listening to their equipment. And you know, that really brings us to the most important piece of advice you will ever get in this job. A good operator listens to their machine. Get to know what your pumps sound like when they're healthy, when they're running happy, because that is the only way you'll immediately know when something just sounds wrong. Which leads me to one final question to leave you with. What's the one sound your pump should never, ever make? Think about it for a second. If you ever hear something that sounds like gravel or a bunch of marbles rattling around inside that casing, that is a very serious problem, and you need to report it immediately. So stay safe out there and keep listening.